Hi guys, this is just a quick review on vertical and horizontal stretches and shrinks, as well as reflections and translations for absolute value functions. I'm just going to get into it. Hopefully this helps. So I'll have our parent function f of x equals the absolute value of x. That should be a relatively familiar function right now. The next thing I'm going to do is I'm going to add a constant up here. I'll have a new function, g of x, g of the absolute value of x. And let's do a, excuse me, let's do a vertical translation. So I'll do plus k. And I'm going to add my slider. So if k is 1, we have slid, you see my mouse, this up 1 unit. Every single position for the y, 1 unit. Because remember, this k is on the outside of the function, so that means that it is a vertical change, and we're adding, so it's going to be a vertical translation. So if I increase that, we slide up. If I decrease it, we slide down. Should be pretty straightforward. I don't think the translations were the things that were giving people trouble. So now this is 0, so we can basically ignore this. I'll actually delete it so people aren't confused. So now I'm going to do plus h. And remember, this is when the inside of the function is kind of the reverse of the outside. So here, if I'm adding h, if I add 1, I'm actually sliding to the left. So the way that we can fix that is by making this minus h. So now if I make h 3, that means that I have slid or translated this 3 to the right. If I make h negative or decrease h, that means I'm sliding to the left. And right here is our final spot. So this is a horizontal translation, 5 units to the left. So I'll bring this back 0. And I'm going to get rid of this now, just to hold the confusion. Now, once again, we'll do reflections. So all that is adding a negative sign. And a negative sign on the inside will reflect it in the y-axis because we're doing a horizontal change. This would go here, this would go here. But if you see when I do this, add the negative, nothing changes because this is a vertically symmetrical graph. Now if I had, let's say I had my h back in here, minus h. Now I move this over 2 units to the right, and if I made this negative, we now reflect the whole thing. Every point is now mirror image. So if I delete this, we're back here. So pick one point. Let's pick this point right here. If this is negative 3, 5, we should expect this to be at 3, 5. So I will put my cursor there, and this is 3, 5, so we should expect this to go here. And then there's my cursor right there. So that happens with every point. So that is an example of a horizontal change, aka a reflection in the y-axis, because the y-axis is acting as our mirror. If I do this on the outside, we'd get a vertical change. So right here, I'm gonna have this go back to 0. I'll just delete this actually. Right here, we have a regular absolute value function. And when I have negative, this will flip in the x-axis because it's a vertical change, and the x-axis is our mirror. So now this just flipped over, so every point that was here is now just the opposite for the y value. So that's what the negative does. The stretch and the shrink seem to be the hardest part for people to grasp. So we will start with a vertical stretch. So that is when A is on the outside. Whoops. When A is on the outside, we have, if I increase A here, pick a point. So right here, We'll say 2. Close enough. There we go. So negative 2, 2. So if I increase a, if I stretch it, if I make this 2, we're going to multiply every point, that is every vertical value, by 2. So this would go 2 times 2 would go to 4, and then this is 3 for the y value, so that would go to 6, and so on. So I'll move this to, I'll actually write the points here. So this is negative 2, comma 2, and then I will go from, and I'll also put negative 3, comma 3, and then we expect this negative 2, comma 2 to just go from here to here. If you look at my cursor, here to here. So that is negative 2, comma 4, and we expect this to go to negative 3, comma 6. And once again, this is if we make a go from 1 to 2. So I will slide this from 1 to 2, and we see that we have stretched each point on this line is now each y value is multiplied by 2. So that's what a vertical stretch is. And that's for any value that is greater than 1 for this coefficient right here. So a vertical shrink is the opposite. Vertical shrink, now instead of so these are the original points on our original function. The vertical shrink means instead of multiplying these by 2, we're going to, if we wanted our scale factor to be 1/2, we would just divide them by 2 or multiply by 1/2. So instead of this being 2, comma 4, I'm going to make it 2, comma 1. And then instead of this being negative 3, comma 3, this is going to be negative 3, comma 1.5, because 3 divided by 2, or 3 times 1/2, is 1.5. So now I'm going to move this a value down to 1/2, or 0.5, and this is our shrink. Vertically, we are reducing the size, and our scale factor is 1/2. So that's a vertical shrink right there. Horizontal stretches and shrinks would be on the inside of the function. And by the way, the vertical shrink, we're shrinking it towards the x-axis, or stretching it from the x-axis. So that's our reference point there. For a horizontal shrink, it's the y-axis. So I'm going to get rid of our a here, and I'll call this b on the inside. I'll get rid of these sliders right here just so it's easier to see my screen and all these points. So right here, this is a horizontal stretch because it's on the inside and it's being multiplied. Okay, so if I have, and like I said, our reference point is the y-axis here because that's where x equals 0. So let's pick a point. Let's do this point right here. Negative 3, 3 again. I guess I didn't need to delete that. And if I'm going to increase b, let's say I increase b to 3, this is the reverse part. This is, once again, instead of multiplying by 3, I'm actually going to divide by 3, or multiply by the reciprocal of 3, which is 1/3. So my new point is going to be negative 1, comma 3, right here. Actually, you know what? I'm going to make this, just because I don't have the slider in sections of thirds, so I'm going to make this. We'll make b equal 2. So this is going to be negative 1/2, or 1 1/2, I should say, comma 3. And then let's pick another point. I'll pick a point in the positive side. So let's say I'll pick 10. We'll do 10, comma 10. And now I'm going to make this, so if I multiply, if I make b 2, that means I'm squishing it in here. So that means that this 10 for the x is going to go to the 5 here. And my y is going to stay the same. So this would be 5, comma 10. It's right there. So we're going to squish this function in for horizontal shrink to get this absolute value function going through both this point and this point with our same vertex because I don't have an h or a k value here. So anyway, I'm going to increase this from b equals 1 to b equals 2. And we can see that we have just squished it in. We've just shrunk it horizontally. So that is a horizontal shrink. And last, we have a horizontal stretch. So I'm going to get this back. And a horizontal stretch is when b is in between 0 and 1. So let's do a horizontal stretch with a factor of, let's stretch it by 2, or basically make b equal to 1.5. So I'll keep these 2 points here, and instead of dividing, I'm going to multiply. So instead of dividing by 2 or multiplying by 1/2, I'm going to take this x value and make it from -3 to -6, not 67, right there. And from, instead of making 10 divided by 2, I'm going to make it 10 times 2. So if we look at this point 20, 10, it's not even on my graph right now, but I can zoom out a little bit, and now we see it over here. And by making this b, I'll bring this back to 1 right now, but our horizontal stretch, we're basically pulling things away from this y-axis. So this point will go here. Every point will be multiplied. So every x value of the point will be multiplied by 2, because once again on the inside of the function, it's going to be in kind of the reverse. So I'll move this over. I'm stretching it out horizontally. And now I'm at 0.5, which is 1/2. And that is a vertical stretch. Sorry, horizontal stretch. So remember, horizontal stretch, we're stretching away from the y-axis. And for a horizontal shrink, we're pushing our function into the y-axis. And for a vertical stretch, we're pushing away from the x-axis, and for a vertical shrink, we're pushing into the x-axis. All right, that is about it for section 3.7.